Hello everyone, welcome to this lesson. So in this lesson, we want to look at modern observability, system health, and semantic correctness as it applies to mass multi-agent orchestration patterns for enterprise scale system, which is my book that I just published. If you've not gotten your copy, please kindly go to Amazon and get a copy by clicking at the link below. It's a very nice book. You're going to like it. Contains a lot of structured architecture for designing an effective multi-agent system for an enterprise. The right way to connect, how to follow policy and compliance, implement governance and responsible AI usage. And then in chapter 6, the last time we discussed scalability, how you scale your agent using orchestration to containerization, and by implementing different storage for different situation, for different memory states. So here today we want to look at observability and monitoring, which is the content of the book, chapter 7 of the book. So if you are new to this channel, please like and subscribe. As usual, I'm just going to give a guide. So the full content and implementation is in the book, and the code is in the Git repository, which I also drop in the book, which if we have time, we may look at the code and how to actually construct the architecture and put them together as a whole, for operation. So, all right. Observability and monitoring, of course, observability is very, very important in software engineering. It is what allow you to have, a an effective software workflow in a system. A system without observability is a system that is ready, to fail. It will fail, and when there is a bug, you may not know what is going on in the system. So traditional monitoring is not enough for AI agents. So when we talk of agents, we can't implement traditional monitoring. It will fail to capture the subtle non-crashing error unique to multi-agent architecture, because agent can be working, normally fine and be producing wrong outputs. Why? Because traditional monitoring is being implemented. So agent must be observed specially, uh, based on their capability, not following the traditional method. So a system can be technically healthy, but still produce poor or absolute wrong, outputs, which is very, very common operation among agents nowadays, because a system may not be down, it may be working and be giving wrong, answers, wrong outputs, hallucinating, and all that. So agent observability must include traces, logs, metric, and quality signals. So you must know when um the agent is giving you quality output from when it is not giving you quality output. That is why you also design for, quality, for what you are putting in and what you are getting out must be properly designed. So distributed tracing show how requests move through agent, tools, and LLM calls. So what we want to look at here is how you should include traces, logs, metric, and quality signal in your agentic system design. How should you implement distributed tracing, because multi-agent system are also distributed system? How should you implement structured log to make agent decision easier to investigate? How can you, track metric latency, error, queue depth, token usage, and cost? How can you implement semantic monitoring track for confidence, quality, escalation, human override? How can you implement dashboard, or how can you make sure that the right team get the right, visualization on the dashboard to monitor the agentic activity? And then how do you implement root cause analysis to help identify whether failure came from data, prompts to model, or workflow? So these are the content of what we have in chapter 7, and let's look at their, guide in the following slide. So technical behavior like latency, error, queue, or uptime and resource usage must be tracked, must be properly monitored and observed in multi-agent system. Semantic behavior must also be observed. Semantic behavior include quality, confidence, hallucination risk, escalation rate, correctness, and business value. So all this must be observed, properly observed, not in a traditional way, but in a systematic way. So agent fails silently. Okay, agent can fail and still be working, but giving you wrong outputs. So traditional software fails visibly with crashes and timeouts. Agents don't fail with timeouts. They may not crash, they may not time out, they may still be working, but obviously there is a failure in the system when they start hallucinating and when they start giving you wrong outputs. So agent system can have 100% uptime and zero exception while producing systematically wrong results. So a compliance agent may return approved for every vendor because its constant is still. So it may be saying approved when it is not supposed to be approved, or it can be giving you approved when it is not even approved. So which is a very, very dangerous operation in the system. So the 4-layer metric model for enterprise agents are, so we have this 4-layer discussed in the book Multi-Agent System for Orchestration Pattern for Enterprise Scale System. So we have the layer 1, which is infrastructure. It focuses on system health. Here you collect metric like CPU, memory usage, agent uptime, and pod health, which is your pod on Kubernetes. And then we have the workflow. So in the workflow layer, you focus on execution, that is execution of task, and the kind of metric that you measure there are task outputs, queue depth, retry count, and P95 latency. And then in layer 3, you have output quality. So here you focus on semantic integrity. So personalization of the agents. How do you measure that they are doing the work they are supposed to do? So here you collect metric like hallucination rates, quality score, and confidence. And then we have the last layer, which is business impact. So here, what you are after is a value. Are the agentic workflow giving you value? Are they giving you what you expect to get out of the system? So, and then here to collect metric, you measure metrics like SLA compliance, outcome value, and escalation rates. So these are the layers and the focus and the key metric that you are expected to collect at this layer to ensure that you have a multi-agent system that is giving you value and quality output. And then that is the content particularly for for the introductory part of chapter 7. And then in section 7.1 we have a distributed tracing. We talked about distributed tracing in depth. So distributed tracing maps the complete tree. So implement open telemetry, which is a platform for collecting logs, and then you can use Tempo or Elastic Cache for visualization, or Grafana, anyone you want. Then the complex tree of spans across agent and LLM. So, and these are kind of traces that you can measure. So multi-agent workflow must have a tracing tree to avoid stressful debugging from manually joining logs. So you must make sure you design a tracing tree, not just collect all logs and store them in one place. You will have problem analyzing them and tracing them to a particular agent. So implementing tracing tree enable you to classify logs uh, and trace particular logs to a particular agent. So agent trace model workflows span across uh, the following trees that we can see in this system. We have orchestration span, we have task span, we have a LLM call span, we have two-core span, we have child agent task span, and two cores must be traced so that downstream failure can be feasible. Make sure you track your two core, know which agent is calling which two. Okay. Observability must not leak private or regulated data. Ensure that you also implement policy so that private and regulated data are not leaked beyond the system. Then semantic span tell you whether the agent results has good or log should be properly structured. So we also have semantic span, which is a personalization of the agent. The actual activity of a particular agent is the semantic span. You know whether a particular agent is hallucinating or giving out or poor output. So you can also implement that. And then we have these four trees of implementation. We have the trace propagation, where you design a function like inject trace ID or span. You assign trace ID and span ID to a particular agent to be able to trace their tool call, their implementation, their operation, and their connection or calling the APIs. So, or design trace ID and span ID into task header to link parallel and sequential steps. We also have span hierarchy. Root starts at the orchestrator, branching into agent span, then LLM tool calls. So for span hierarchy, you start from the orchestrator and then branch into agent span, LLM, and tool calls. That's how you define the span. And then we have instrumentation. You can use a function like batch span processor for high throughput agent to cut export overhead. So these are the functions you can implement here to measure high throughput. And then we have visual legibility. So show a 23-minute review, 18 minutes on LLM inference, 4 on stored ERP. So you can also trace visual legibility to trace how individual agent calls LLM and also calls or interact with the ERP system. So this is what we have in distributed tracing. Semantic span, we have a span hierarchy, we have LLM call, we have severity run book, notification channel, and what have you there. So in section 7.2, we have logging, strategy, and aggregation. So how do you implement logging? So structured logging standard. For structured log, make sure make sure all the logs are structured, and make sure you implement logging strategy. Okay, and logging strategy, of course, must support operation, security, compliance at the same time. So logging is very, very important and must be structured and must support operation, security, and compliance. So logging must also be collected within a predefined policy. Semantic attribute make traces actionable for quality. So make sure you collect semantic attribute like contextual data for Lego agent, this page count, clause count, model prompt, and versioning are the kind of things that you can measure here. Then escalation triggers. Record whether escalation was triggered and why. So make sure you also record or escalation triggers from individual agent, including the orchestrator agent. And then audit trails, very, very important for compliance. I must span record source fashion. So you implement audit trail to ensure that every agent operates within a predefined compliance principle. And then we have structured logging and routing. So using low-K and log category to separate noise from compliance and security audit is very, very also important. So you can collect the log categories that you should collect. Remember, we say you should implement structured logging and make sure your log strategically supports operation, security, and compliance all at the same time. So for structured logging, you can use automated routing for task lifecycle, LLM interaction, compliance event, and security. So for compliance rotation, compliance log go to immutable long-time storage within 7-year retention via the Loki pipeline. So this is how you can implement a compliance log. Make them immutable, long time, you can keep them for 7 years within Loki pipeline. Then quality signal. Every LLM call include hallucination scores and reasoning indicator to track drift over time. So every LLM call must include hallucination score. So make sure you also measure hallucination score in LLM, because if the LLM, which is the brain of the multi-agent system, is hallucinating, then the whole system will also generate a very, very poor output, because LLM is the foundation. You only build agent on foundation. So if the foundation is faulty, then you have, you have a collection of faulty rooms and faulty roof, and everything you put in on the foundation will also crash. So if LLM is hallucinating, the whole of the agent will generate wrong outputs. So make sure you measure hallucination score in LLM. PII reduction. Regex stages strip sensitive keys like SSM or API key before they reach operational strategy. So PII reduction is very, very important. Implement Regex stages to strip sensitive keys like SSN and API keys before they reach operational storage. So that is the log that you can collect in those stages. Then we have metric collection and utilization. So how do you collect metric and utilize metric? If you are working, if you are deploying to, a cloud platform like Azure, we always use Azure as an example, because that is the major platform where I build data engineering and agentic workflow mostly. So you can use Azure Monitor to collect metric. You can use log analytic workspace to analyze log, and then you can process the logs and the metrics and visualize using Power BI, or you visualize even using Azure Monitor. So segmenting visualization by audience to provide technical health, business outcome, cost metric. So all logs and metric are not meant for everybody, okay? Some logs are meant for security engineers, some are meant for business users, some are meant for agentic AI engineers, some are meant for integration engineer. Make sure you structure your log, the metric, and make sure metric and logs are visualized for particular personnels that need to see them. So metric collection and visualization, you can collect, as we have discussed, you can collect infrastructure log, workflow log, output quality, user and business impact. So these are KPI that you should look into. They are the KPI, key performance indicator, that you should implement for. So fleet health is very, very important. Real-time start panels for healthy agent. Your target should be greater than 98% and active in-flight workflow counts. So throughput and latency, time series chart showing P95 task duration by capability and queue depth, it's map to identify bottleneck. So you can collect throughput and latency, and there you'll be having a real-time charts or time series charts to see how the agent is performing in real time using P95 task duration by capability. Then economics and quality. So rolling 1 hour view of LLM token consumption versus P50 and P10 quality score distribution. So you can also visualize economic and quality by visualizing LLM token consumption. Then we have drill down. Operator can jump from a greater than 5% error rate spike into the affected agent distributed traces. So, or make sure you also implement drill down. Okay, you can drill down to 5%. You can drill down to what is happening at when a particular agent is making, is utilizing token or calling LLM or calling tools. So make sure you also drill down to a particular agent. Do not just collect generic logs or generic metrics. Drill down to see what is happening at the individual agent level. So real-time monitoring dashboard, as we have said, make sure you take into consideration when you are visualizing a metric. Consider executive utilization, consider engineers dashboard for engineer, build dashboard for auditors, also build dashboard for operation teams. Then we have alerting and incidents, which is the content of section 7.5. Alerts. Which alert should you set? Which alert should you set, or which alert should you receive? So that is what we discuss here. Alert correlation, stopping the alert storm, preventing alert fatigue by grouping related symptoms into single diagnosable incidents with runbook. So we have severity tiers. Set alert for severity, like critical 24/7 page, high business hours, medium ticket, and low weekly review. So you can set this level of alert based on severity: critical, high, medium, low. So you set weekly alert for low severity level, set medium alert for medium severity, high alert for business hours, and critical 24/7 alert, 24/7, that is all the time. So correlation rules, linking alerts to particular function. So you have groups, you have two core error rate high, fleet health critical, set alert for all these functions. SLA miss rate, set alert. Single database outage incidents, also set alert when there for database outage. So when there is database outage, you'll be able to know when LLM when agents are missing SLA compliance. Set alert for fleet health critical, and set alert for two core error rate when it is high. So actionable runbook that you should implement. So every high or critical alert must link to a runbook URL. An alert without a runbook is noise. So runbook, of course, enable you to process log and see the output of everything that is going on in your system. So if you are setting alert without runbook, it's just a noise. It's just a stochastic. It's just like you're implementing a stochastic parrot, which is just talking, alerting anyhow. So set runbook, implement runbook for alerting. So false positive target. We track and review false positive rates monthly, targeting less than 2% for critical alerts to maintain responder trust. So collect alert for false positive target, so that you'll be able to measure whether whether your agents are giving you false output or true output. So that is the content of chapter 7.5. In summary, we have there that good alert tells the right people about the right problems at the right time. So good alerts tell people about the right problem at the right time. Okay, it's very, very important that you set alerts. Bad alerts create alert fatigue. Do not implement alert without a runbook. So make sure you put into consideration severity level, use runbooks, use notification channel like Teams, like Slack, etc., email, or false positive target must be implemented. Suppression rules must also be implemented. Alert correlation must be put into practice. Okay. And then in section 7.6, we have performance baseline. So how do you set statistical or measurable baseline to detect deviation before failure? It's very, very important, guard. It ensures your agents are performing excellently. Baseline tells you what normal tasks look like. Okay. Baseline must must be recalculated because system, model prompts, and workload changes over time. So things change over time. So agents can be behaving well today and tomorrow they can just change due to stress. So baseline must be recalculated because system, model prompts, and everything changes over time. So baseline should exclude non-incident and deployment, otherwise normal behavior become part of normal debugging. So normal behavior become part of what is not normal. Abnormal behavior become part of a normal routine or normal outcome. So statistical baseline detect deviation before failures, normal versus anomaly. So we define a normal range as mean plus or minus 2 standard deviation and an anomaly threshold at 3 standard deviation. So you define your normal range and an anomaly threshold so that your agent do not operate beyond those set baseline. So also make sure you implement drift detection. So drifts are abnormal changes. Deviation from giving correct output is a drift. So you can use seed score analysis to flag significant deviation in token consumption or quality score. Then you can also use data rigor, which require at least 100 samples before production alerting. So update baseline weekly. Update baseline weekly. You don't just build agents and leave them to work. Make sure you always update your baseline. And then we have section 7.7 where we have debugging. So debug information behavior, an agent may not be able to reveal this. So make sure always you always debug information or behavior. And then for this, we have this 5-layer RCA framework. So a systematic approach to working backward from business symptoms to original technical root cause is what we design here, which are RCA framework. And then we have 5 layers. Layer 1 is to fix. So this is where you increase pool size by fixing the agents. Layer 2 is infrastructure, where you implement high database latency. And at layer 3, we have low inventory signal, which is agent layer. So also designed for when you have low inventory signal. So RCA, of course, is root cause analysis. So move from symptoms, this help you to move from symptoms to workflow behavior. So you move from getting symptoms, getting poor quality output to, implementing and managing workflow behavior. So you can do this as infrastructure level and then conduct root cause analysis. So database connection as layer 1 and increase pool size also. Then layer 3, we have low inventory signal. And at layer 4, we have race condition, which is workflow layer. And at layer 5, we have duplicate purchase. So this is how the flow of root cause analysis, how you can analyze what is causing a particular error layer by layer. And that is all we have in chapter 7. So read from the book to study how to implement this. And then we have the general observability and monitoring architecture here, which are basically ways of collecting, tracing, metric, log, quality signals, and incident response in multi-agent orchestration design. Then at the top layers, we have the general architecture, which is user request to orchestrator to agents to LLM calls to tool calls and to workflow outcome. All these are directed to telemetry collection and logging layer, which is your observability layer, where you collect log and semantic signals. And then this is where you collect traces, metrics, structure logs, quality score, confidence score, escalation rate, and human overrides. So also human in the loop for things. You can also collect human activity log here. And then this layer is connected to the layer where you visualization. So this is collection layer, telemetry collection, log collection, metric collection, trace collection, and quality score collection. And then this is when you have collected and clean using KQL in real time. You can visualize using a Prometheus metric. You can visualize distributed tracing. Visualize metric using Prometheus, or visualize distributed tracing using Tempo, or visualize log using Loki, log aggregation. You can use Loki pipeline. Visualize quality score confidence escalation using Grafana dashboard, which has beautiful chart like pie chart, bar chart, line chart, area chart, and so on. Then you can, for human, you implement alerts. So human receive the alerts on all these logs that you are collecting. So we have alert and routing, which is bi-directional, connected to alerts or incident response, to root cause analysis, where you measure the root cause analysis, classify them based on infrastructure, database, agent, workflow, and so on and so forth. Then we have the post-mortem improvement. So when you receive all these alerts, visualize the dashboard, then you implement and correct and debug and resolve whatever the issue is in the system. And all this, what you obtain by implementing this architecture in your multi-agent system design is end-to-end visibility. You see the activity of all the agents, their pattern, their behavior, everything is visible, clear. And then you have faster debugging instead of looking for one error or for about 1 week. You have structured workflow, structured log, everything visualized in real time, which enables clarity. And then you have quality monitoring. You not just be collecting logs and storing them. You have quality monitoring. You have you see the visibility. You see everything happening in the system clearly, and you can judge, and locate carefully any error or poor quality output from any agent. And then you have operational trust. So by doing and implementing this, you will be building a trustworthy and responsible AI or multi-agent system design. So key insight, what is the outcome? What will you achieve by implementing this structured observability and monitoring? Number one, we have health system, okay, and correct outputs. So you have healthy system and you have correct outputs. Then we have observe technical plus semantic behavior. So everything will be under observation. Technical capability of the agent and semantic behavior of the agent. Semantic behavior is the personalized behavior of the individual agent. It will be clear and feasible to you as the engineer. And then lastly, we have correlate signal for faster root cause analysis. So you have faster root cause analysis, implementation, and measurements, okay, because you have all your inputs. So to, calculate your statistical analysis of everything in the workflow will be easy for you. So this is what we have in observability and monitoring implementation in multi-agent orchestration pattern for enterprise skill system. So if you are new to this channel, please kindly like and subscribe, and also share with your friends and your co-workers and your colleagues. And then also get a book to learn more on how to design for observability and monitoring in multi-agent system workflow. Thank you for listening. See you in the next chapter, which is chapter 8, where we'll be talking about security and governance in multi-agent system. Bye for now.